In this video, we're going to look at the special case of side-side angle when trying to use your law of sines. And that is when two sides and a non-included angle are given. And in that case, when this happens, then you may end up with one triangle, two triangles, or no triangles as your answers. So in the last example, when it's not a side-side angle case, your only possibility is to have one triangle as an answer. Now you have to be able to recognize what is given, and if a side-side angle or two sides and a non-included angle are given, then you know that you have to check for that possibility of having two triangles or for not even having any triangles at all. So let's now look at an example of Learning Target 9.5b, where the triangle that is given, or the parts of the triangle that are given, are the side, and an non-included angle. So it wants us to solve the triangle again, so again, find everything that's missing. So to start this problem, just like I did the last one, I want to just kind of sketch my triangle. Doesn't matter, again, what the triangle looks like, or where you put the sides, the vertices. So again, I just labeled it with A, B, and C some way. My A, they tell me, is 127, so again, obviously my picture is not correct, but it doesn't matter. I just want it to give me a general idea of where everything is located that was given. So my angle A is 127, side A is 63, and side B is 42. So by looking at the picture, I see that I am given both my A's, both angle A and side A, so I can use that to set up my law of sines. So I do the sine of 127 over 63, and that equals, and now my only choice of places to go is to find that angle B, since I know what side B is. So since I'm trying to find the angle, it's going to be the sine of B over the side, which is 42. Now I'm going to cross multiply and divide, so I end up with 42 times the sine of 127 divided by 63. And that has to equal the sine of B. So I'm going to go ahead and divide out the left side. So take the 42 times the sine of 127 degrees and divide it by 63. And when I do that in the calculator, I get the decimal 0.5324 equals the sine of B. And now remember back to when we solve for angles. To find what the angle is, I do the inverse sine. So the inverse sine of 0.5324 will be my B value. So in this case, the B is equal to 32.17. So I know for sure that that's going to be my B value. Now that might possibly end up being a B1 value if I find that my second triangle does exist. So let's go ahead and figure that out now. So what I do is I take that angle that I just found and subtract it from 180 degrees. So 180 minus 32.17. And when I do that, when I subtract those two, I get 147.83. Now that would be my possible second B value. So what I need to do to see if that actually works is I'm going to take and combine it with the angle I already have. So the angle I already have is 127. I'm going to add 147.83 to it. And when I do that, I get 274.83. Now I know that in a triangle I can only have 180 degrees. So since those two combined alone is well over 180, there's not even room for that third angle, because keep in mind that third angle, all angles in this case, because they're in a triangle, are always going to be positive. So that tells me that this I can just cross out, and there is no second triangle. Now I tried for it, didn't get it to work, so it just crossed out. So now I have to finish out this problem for the case that there's only one triangle. So I know what B is. So now that I know what B is and I know what angle A is, I can go ahead and add those together. So 127. So 127, oops, just try that again. 127 plus the 32.17. And that gives me 159.17. Take 180 minus that. And that gives me an answer of 20.83 degrees. And that is my C value, angle C value. Now the last thing I need to do is find side C. So again, I'm going to set up my proportions, set up my law of sines. So I'm going to stick with the one that I knew both of. So the sine of 127 over 63. And that has to equal, now I'm looking for C. So it's going to be the sine of angle C, or the 20.83 that we just found, over side C. So now I cross multiply and divide, and I get that 63 times the sine of 20.83 divided by the sine of 127 has to equal C. So I type that in my calculator, and I get, and I'm going to write over here because I was out of room, that side C is equal to 28.05. Now be careful with the letters. You want to make sure that your little c is not the same as your big C, so try to make a difference. For sure on your angles, just make sure you put the degrees on so I know which ones are the angles and which ones are the sides. So there is my law of sines, and this one only found one triangle. So now let's look at another example where you're given two sides and a non-included angle. So again, they want us to solve this triangle. So I'm going to start out by drawing a triangle, labeling it A, B, and C. They tell me that angle B is 52, so this angle in here is 52. Side A is 6.5, and side B is 4.7. So I can go ahead and use the 52 and the 4.7 since they're the corresponding angle and side. So the sine of 52 divided by 4.7 equals, and now I do know side A, so that tells me I should find angle A. So the sine of A over 6.5. And now cross multiply and divide. So 6.5 times the sine of 52 divided by 4.7 has to equal the sine of A. And when then typing that into the calculator, I get an answer of 1.08 equals the sine of A. And then knowing just from our basics facts of sines and cosines, they can't be greater than 1, so that means this doesn't exist, which means then that there is no solution or no triangle in this case. So a triangle does not exist that has an angle of 52, one of the sides being 6.5 and the other side being 4.7. So now let's look at one more example of learning target 9.5b. So they want us to solve triangle ABC when angle A is 62 degrees, side A is 32, and side B is 34. So again, I'm just going to draw myself a little sketch of this triangle. So A, B, and C. A I know is 62 degrees, so I put a 62 in there. Side A is 32 and side B is 34. So again, there is a set that I know of both the angle and the side opposite it. So I'm going to go ahead and set up my law of sines. So the sine of 62 over 32 has to equal the sine of, and now I know side B, so I've got to find B first. So the sine of B over 34. So I'm going to cross multiply and divide. So 34 times the sine of 62 divided by 32 has to equal the sine of B. So now remember, in order to find what that B value is, we have to do the inverse sign. So first let's get the decimal, I guess. So the decimal to the 34 sine of 62 over 32 is 0.9381. Thankfully, it is not over 1, so there is going to be a solution here. So now I do the inverse sign, so sine to the -1 of 0.9381. And that's going to equal my b value. So in this case, b is equal to 69.74. This is talking an angle, so I have to put that degree mark on there. So now, like we did back a couple problems ago, we've got to check for that second triangle. So we're going to take the answer that we just got, do 180 minus that answer, so minus the 69.74. When I do that, I get an answer of 110.26. And now I need to check to see if that works. So I take that angle, so the 110.26, I add it to the angle that they gave us, so 62. And that comes out to be 172.26. It is under 180 degrees, so that tells us that yes, there is a second triangle. So this b value that we found the first time, so the 69.74, that's going to now be our b1 value. And then this answer that we just got over here, the 110.26, that's going to be our b2. So then what we got started there with the 172.26, that's going to help us find C, since we know that the two angles that are currently in the triangle add up to be the 172.26. To find the C, and that's capital C there, so the C value is going to be 180 minus the 172.26, which gives us a C value, or a C2, because this is our second value, of 7.74, or it will be, I should say, our second value, because that all belongs in that second triangle. So let's go ahead and just finish out this problem. We'll come back to the first problem. So now I know what this angle for C is, so let's find the side C. So I'm going to set up the two that I knew, so the sine of 62 over 32 equals, and now I need to find C, so it's going to be the sine of 7.74 divided by your C value. So do your cross multiplying, so 32 times the sine of 7.74 over the sine of 6.2, not 6.2, 62. Sorry, it looked like a decimal up above. So the sine of 62. Type that into your calculator, and then you get your C2 value, or your second C value, to be 4.88. So that takes care of our second triangle. So let's go back and finish the first. I just found out what B is. So I'm going to do something similar to what I did earlier, and I'm going to take what they gave us, so the 62, and add to it what we just found, the 69.74. So in this case, that gives me 131.74. So I subtract 180 minus that, and I get an answer of 48.26 degrees, and that equals our C value from the first triangle that we're finding. Now the last thing I need to do here is find that side C, so that's where that law of sines comes in. So again, keep the sides that we know, so 62, sine of 62 over 32 has to equal the sine, and now we need to find side C. So I need to use my angle C, so 48.26 over the side C that I want. And now cross multiply, so 32 times the sine of 48.26 over the sine of 62. And that's going to equal the little c value. So I type that in the calculator, and I get that little c, or C1, because from the first triangle, is going to equal 27.04. And there it is. So we end up with two different answers, two different triangles. My first one being that I have a B1 value of 69.74, a C1 value, so that tells me that that's in the same triangle, of 27.04, and a C value, an angle C value of 48.26. Whereas our second triangle has a B2 value. So in the second triangle, the B value is 110.26. The C value is 7.74. Remember to keep your degree mark on there. I didn't do that on either of those. Or down here. So always have that degree mark just so you know which one is the angle and which one is the sides. And then for that second triangle, we got a side length of 4.8. So those are your answers. The red ones were for the triangle 1, and somehow mark your work. So whether that means circle it like that and say, oh, circles are from the first triangle, or I could have just kind of put first triangle at the top of this side. So I know all the work over there on the left is for the first triangle. And then off to this side over here, put something like second triangle. So I know again that all the work over on this side of the page is for the second triangle. So that's your learning target 9.5B. Just like you saw in the last few examples, you could end up with one answer, one triangle that works, no triangles, so no solution, or in this case, two triangles. So remember, you always have to check for that second triangle, otherwise you're missing out on possibly finding a whole nother set of numbers that could work.